Hello.
Hello, can you
Hello,
hear me?
yes, I can hear you.
Okay. We'll continue with trigonometry. Do you have any doubts? If you have done yesterday something, tell me. Exercise 12. Have you tried something?
Yes, sir. I had a doubt in the 31st one of exercise 12.
Okay. Before that, everything was sorted.
Yes, sir.
Okay. Exercise 12.
Then I had a few more doubts in exercise 11.
Okay. This is the equation. Tan mx is equal to cot nx is equal to 0. You have to solve for x and find the general solution of this equation. So the obvious thing to do is to convert it like this, right? Tan mx is equal to minus cot nx, right?
Yes, sir.
So now if I can write this as tan something, it will be nice. So I can write it that tan pi by 2 minus nx, right? Because I
Yes.
cannot solve an equation when it is tan is equal to cot. No, I have to solve something like tan is equal to tan.
Yes, sir.
So I've converted cot nx to pi by 2 minus nx tan. And I also know that tan of minus theta is equal to minus tan theta, right?
Yes, sir.
Because sine is going to become negative, even the cos doesn't become negative, right?
Yes, sir.
So therefore, this can be written as tan of nx minus pi by 2, right? Correct?
Yes, sir.
So now you can apply the general formula for tan, and now you can say that mx is equal to k pi plus nx minus pi by 2, right? K I have used because m and n are already being used, right?
Yes, sir.
So you get m minus n x is equal to k pi minus pi by 2. X is equal to 1 by m minus n, or k by m minus n into pi minus pi by 2 times m minus n. This will be my answer. K is an integer, m and n are also integers as given in the question. Okay.
Yes, sir. So that's the final answer, right?
Yeah, obviously. What else is it?
I didn't get it.
I didn't get it. And
Sir, I didn't do the steps you did.
so why? What
No,
happened?
like I understood right now, but when I was doing it, I didn't do it.
But this is what we have been doing, no? In this exercise. Before this, also you have solved some questions where it is tan is equal to cot, right? Question
So
number
I made it
24.
1 by 10.
Question number 24, for example. You solved a question where it was cot is equal to tan something, right?
Yes, sir.
How did you solve it? By
So can you
converting
make
cot to
cot
tan.
into tan?
That is what I have done here.
Like 1 by 10.
But I'm not doing it like that because that doesn't help me solve. That doesn't give me an equation like tan x is equal to tan y, right?
So like you took complement of tan. I had taken like reciprocal of tan.
But reciprocal, does it help? Reciprocal doesn't give you an equation like this, no?
Yes, sir.
Reciprocal gives you some tan into tan or something. If
Yes,
you
sir.
had taken reciprocal, you would have gotten tan mx tan nx is equal to 1 minus 1, right?
Yes, sir. This is what I got.
But after that, you can't do anything from here. Like you don't know what to do now. So therefore, use the stuff that you know. You have to get it into somehow in this type of form. This type of form you get, you'll get the answer. So therefore, I will take complements, right?
Yes.
Okay, what else?
So in exercise 11,
Hmm.
the so the 18th question,
Hmm.
once like you get two different equations, but then like how do you like collate that into one form?
What is the question saying?
Cos
What is the
theta
question asking you to do?
find the most general value of theta for cos theta equals to minus 1 by root 2 and tan theta equals to
You have missed out on the most important 4-5 words. Find the
both the
most general
equations.
value of theta that satisfies both of the equations. Right?
Yes, sir.
It has to satisfy this and this both. So you'll get some general values from here, some general values from here, right?
Yes, sir.
You have to choose the common ones which satisfy both. How do you collate? As in, how do you collate means choose the common ones.
So what I had done was like I had taken like cos is negative and tan is positive in the third quadrant. So that from that's why I used it as pi plus x as in whatever angle. So pi plus pi by 4. So I got one for cos theta and one for tan theta.
What 1 for cos theta? What do you mean
I
by
got
1 for
2
cos
n
theta?
pi plus minus 5 pi by 4 for cos theta and n pi plus 5 pi by 4 for tan theta.
This will be 3 pi by 4 also gives this. No, why are you going to 5? When 3 pi by 4 will also serve the purpose. What is the need to go to 5 pi by 4, right?
So I had done it as pi plus pi by 4 because so it'll like end up in the third quadrant. Was that necessary?
Why not pi minus pi by 4? That will not give minus 1 by root 2.
So because then it'll like pi minus will become the second quadrant, right?
So what? Right now I'm just
So
solving
because it
cos
said
equation.
satisfy both the equations, I thought like because cos is negative in the second quadrant, but tan is positive. But
Tan is positive in the second
sorry,
quadrant.
tan is negative. So that didn't satisfy the second equation.
Solve this in the equation individually. Don't worry about simultaneous solutions. Later you can check common answers. What is the individual solution for this? What is the
Okay,
individual
yes.
solution for this? M pi plus pi by 4, right?
Yes, sir.
Then check now make a list of some angles that come here. If you put 0, what comes? Plus minus 3 pi
3
by
pi by
4.
4.
If you put 1, it comes 2 pi plus 3 pi by 4 and
11
2
pi
pi
by 4.
minus. So 5 pi by 4 and what comes is 11 pi by 4. And if you put 2, now it will become very big, so I'll ignore those for now, and I will see here. If you put 0, you get pi by 4. If you put 1, you get 5 pi by 4. If you put 2, you get 2 pi plus pi by 4, so 9 pi by 4. 3 will give me 3 pi, so 13 pi by 4 will come 3. So if you put 2 here, there's 4 pi, 2 here, 4 pi minus 3 pi by 4. So 16 minus, so 13 pi by 4 is coming here also. Do you realize 13 pi by 4 is coming?
Yes, sir.
So what are the common answers?
5 pi by 4 and 13 pi by 4.
So the series of answers that satisfy will be 5 pi by 4, 13 pi by 4, and you could possibly find another one that satisfies. Next one will not satisfy, the next one will satisfy. 4 pi plus pi by 4, so 17 pi by 4. No, wait. This is n was how much? M was 2. No, M was 3, 4, 5. 5 pi plus pi by 4. So 21 pi by 4. It is at a gap of 2 pi, right?
Yes, sir.
So 2n pi plus pi by 4, where n can go from 1, 2, 3. It will give you all the angles.
Okay, yes, sir.
No, 2 pi nahi. N pi plus pi by 4, where n2 will not give the answer. So n can only be 1. Okay, fine. So you have odd 5, 13, this series 5, 13, 21 you have to represent, right? So this is basically 2 8 8. So it is you can write it as 5 plus n minus 1 into 8 actually. N is 1, then it will give 5. N is 2, then it will give 13. N is 3, then it will give 21, right? So basically 8n minus 3, right?
So at the back of the book it's given 2n plus 1 pi plus pi by 4.
2n plus 1 pi plus pi by 4.
Yes, sir.
Fine,
2n
that is
plus 1
also
in the
right only.
brackets.
That is what we were writing in the beginning. It's just that odd, which pi you added? Pi plus, so odd pi plus pi by 4, then next odd pi. So 3 pi plus pi by 4. That is how the answers are coming. And this is 5 pi plus pi by 4. Right?
Yes, sir. So odd pies.
Odd pi is plus pi by 4. That is how you have to do. You don't have to solve it immediately at once, get the final answer. You have to solve it individually. What is the answer? See the possible angles. Individually here, what are the possible angles, and take common angles.
Yes, sir.
Once you get common angles, you just have to write a pattern for it. What is
Yes,
the
sir.
pattern? What is the next one?
So some of those questions had illustrate, so I didn't do those. Was this like construct the angle whose sine is 3 by 2 plus root 5? Or like
Construct the angle, मतलब find that.
24, 29, like that. They were like drawing questions.
That is just, no, that is just saying find the angle, dude.
So construct meaning like not physically construct.
No, find y. For example, 24. Given the angle x, construct the angle y means find the angle y. First, you will have to find. No, how will you physically construct without finding? Can you physically construct without finding y?
No, sir.
To find y, that is the question. 24th one. Find y such that sin y is equal to 2 sin x. So 2 sin x. Given the angle x, construct the angle y. Okay. One second. हाँ मतलब you will just use the general formula, right? So sin y is equal to 2 sin x. So I will just say there will be some angle y which will be equal to sine inverse 2 sin x, right?
Yes, sir.
Y should be this angle. So the general angle will be simply y is equal to n pi plus minus 1 to the power n sine inverse 2 sin x. Anyway, it's not important. It's fairly straightforward. You just have to say that what is the y that gives me this, right? So it will be sine inverse of this, right?
Yes, sir.
And once you have that, you just construct the general angle. This is a theta, so you're just doing n pi plus minus 1 to the power n into theta. That is my y. So ignore that. Do the exercises. Your the next exercise. For example, do question number 33 right now. Example 12, question 33. Or actually, before 33, do question 32. Question 32 says tan of pi cot theta.
So for 33, we can just say like take it as like a minus b. So like a minus b equals to half, so it's 30.
So
And then like pi by 6. So and then you can form two equations.
it is a general answer, no? It is not just pi by 6, right? How is it just
Yes,
pi by 6, dude?
no, sir. Then you can like form the general solutions.
Yeah, then you have to cancel and solve for theta and phi
Yes, sir.
from the general solutions. But solve this first. 32. The first step is pretty standard here. Cot you have to convert to tan, but not by doing reciprocals. You understand?
Yes, sir.
Don't do reciprocals and convert to tan. That is useless for solving an equation. Make it like this: tan of pi cot theta is equal to tan of pi by 2
Pi by 2
minus pi
minus.
tan theta.
Yes, sir.
Then write the general solution. Now it can be written as a general equation. What are you getting when you write the general solution? Hello?
Hello.
What are you getting for the general solution here?
So I'm doing it 1 second. So you have to simplify and find tan theta, right?
What is the next step here? Tell me the next general solution. What do you have to do? How will you write this? If tan x is equal to tan y, what is the general solution? Hello?
So for tan, it's n pi plus the angle.
So what will you write here?
N pi plus pi cot theta.
Is equal to what?
Um, N pi plus pi by 2 minus pi tan theta.
Both sides you will put n pi plus this. So right now the solution
So
of this
otherwise
I
you
should
can
write.
leave that as pi cot theta. So you can put it only for the right side otherwise. N pi
Don't
plus
put
pi
n
by
pi
2 minus
plus
pi
on
tan.
both sides. No? That doesn't make any sense.
Yes, so only on like the right side, I guess.
Now this is still an equation. This is still not solved, right?
Yes, sir.
Pi you can cancel from everywhere, by the
So
way.
you can take pi out, yeah.
You'll get tan theta plus cot
So
theta
n
is equal to n plus 1 by 2.
plus half. Yes, sir.
Okay. This is now a new equation. You have to solve for theta.
So
So this equation you can solve because this
now you
can
can
become
take
a
it as 1 by
quadratic.
tan, right?
1 plus tan square theta is equal to n plus half tan theta, right? So it becomes a quadratic equation like this: tan square theta minus n plus half tan theta plus 1 is equal to 0.
Yes, sir. And you can multiply by 2.
Or you can just solve it like this: tan theta will be equal to
So then,
n plus half plus minus.
so 2n plus 1 plus minus root over 2n plus 1. I took with 2, like I multiplied by 2.
How does that change anything?
N plus half square minus, yes, sir.
Now, the thing to remember here is that not all values of n will satisfy this. You have to ensure that this is positive, right?
Yes, sir.
So for roots to exist, n plus half whole square is greater than equal to 4.
Yes, sir.
N is equal to 1 will not work, right?
So 2 or greater.
2 or greater, minus 1 will also not work. Minus 2 will also not work.
So 0
Minus
also won't work.
3 will work. So in the positive sides, at least it should be 2 or more, right?
Yes, sir.
So once you get this, then you can say that theta should be n m pi plus tan inverse of this thing, right? You understand? Because this is a constant, so it will be some angles tan will be this, right? That angle is tan inverse of whatever is here.
Yes, sir.
So n, and one more condition that you should know is that n should be greater than 1 or n should be less than minus 2. Minus 2 will not work, 1 will not work on this, right?
Yes, sir.
because you have the roots
So
have
n
to
can
be
be
real.
any integer apart from like those 4 values, which is not included.
1, 0, -1, -2 cannot be done.
Yes, sir.
You could have said that here only, because tan and cot are reciprocals of each other. X plus 1 by x. Now x plus 1 by x will either be greater than 2 or less than -2. You will learn this later, but the reason that happens is that we can prove it. For example, one second. So we can prove that x plus 1 by x has always got to be greater than 2. Why? Because x plus 1 by x minus 2 is equal to root x whole square plus 1 by root x whole square minus 2 into root x into 1 by root x, right?
Yes, sir.
So this is root x minus 1 by root x whole square. So that must be greater than or equal to 0, right?
Yes, sir.
So therefore, it implies that x plus 1 by x must be greater than or equal to 2. Right? You understand?
So till root x minus 1 by root x whole square greater than or equal to 0.
Till means what?
So just the last thing which you said, I didn't get.
What is this equal to?
X plus 1 by x minus 2.
So that is also greater than or equal to 0.
Okay, yes, sir. Okay.
I'm just converting this to this. No, so if this is
Yes,
greater
sir,
than
yes.
0, that is also greater than 0.
Yeah.
Similarly, this also you can prove by proving that root x plus 1 by root x whole square should also be greater than or equal to 0.
Yes, sir.
So that implies that x plus 1 by x plus 2 is greater than or equal to 0. X plus 1 by x is less than or equal to -2. So if x is negative, then this has to be true. If x is positive, then this has to be true. Therefore, tan theta plus 1 by cot theta or plus tan theta plus cot theta cannot be in between -2 and 2. Has to be beyond it, either greater or lesser.
Yes, sir.
Okay. Fine. You attempt the rest. We will actually move on. We'll go to chapter number 7. Chapter number 7 and 8 are related and very important. So here what we'll be learning is the sine of, say, a plus b and cos of a plus b. A and b are two angles. So we'll be learning what these are. This is sine a cos b plus cos a sine b. And similarly, cos of a plus b is actually cos a cos b minus sine a sine b.
Same, yes.
Okay. So how does this come? That is what we have to figure out. These are two formulas. We will do the proof of this one, the proof of the second one. The proof of the second one is in the book. You can read it. It is very
Okay.
similar to the proof of this one. So once we can prove this formula, from these two formulas, we can derive a lot of results. Like if we know these two is correct, then after that, a lot of things will become very easy. So it is very important because of that reason. The proof of this comes by a geometrical proof. I'm going to try to prove this one, sine of a plus b.
Yes, sir.
So if this is my origin and this is my OA line, I will draw another line OB and OB line, and this is my angle A. This is my angle A right now. And then if you rotate OB line further, you will get another line OC, which will be your angle B. right?
Yes.
This is my angle B. Ultimately, what I need to get is sine of A plus B, right? Correct.
Yes, sir.
So I need to drop a perpendicular from C to OA, right? Then only I'll be getting sine of that total angle, right?
Yes, sir.
So let's drop a perpendicular from one point here P to this point here M. Correct. Now,
Yes,
if I
sir.
wanted to say something about sine of angle A, then I have to drop a perpendicular from some point here, right, to this, right?
Yes, sir.
But before you do that, drop perpendicular from P only to B. Basically, from P you are dropping two perpendiculars, one on OA, one on OB.
OB.
Okay.
Yes.
And from that point, let's call this point N, drop a perpendicular here, right? This is
Yes, sir.
Q. And make a line parallel to N, parallel to OA through N, like this, parallel line. So that means that if this line and this line are parallel, this is also 90, right?
Yes, sir.
And this is my R. So now what I want to do here is somehow get the sine of the overall angle, right?
Yes, sir.
Correct. So sine of the overall angle is clearly going to be equal to perpendicular by hypotenuse, no?
Yes, sir.
So PM by OP, right? Correct.
Yes, sir.
PM by OP is going to be my sine. Now PM can be thought of as PR plus MR, right? Correct.
Yes, sir.
PR plus MR by OP, right? So I will split it as PR by OP plus MR by OP, right?
Yes, sir.
Correct. Now PR, uh, okay, yeah. So MR, first of all, he will write as NQ actually, okay? So PR by OP plus NQ by OP, because of MR is same as NQ. This one is same as this one, no?
Yes, sir.
So MR is same as NQ by OP. Now what he does is multiply and divide by same quantity. So ON. Suppose you have NQ and you divide by ON, you can multiply by ON and divide by OP. That doesn't change this
Change
ratio, no?
anything. Yes, sir.
So NQ by ON, see what is that? NQ by ON looks like sine of A, right? In this triangle, NQ by ON.
Yes, sir. Sign in.
So this is sine A. What is ON by OP? Now look at the big triangle PNB. ON by OP. It is cos of angle B, no?
Yes, sir.
Okay. Similarly, PR by OP also multiply by NP and NP. PR by NP, NP and OP, right?
Yes, sir.
Now look at PR by NP. PR by NP. Now our job is to basically find out what this angle is. So if this angle is A, then this is 90 minus A, right?
Yes, sir.
So this is 90 minus A.
Yes, sir.
So this is A.
Yes, sir.
So this is 90 minus A.
Yes, sir.
So this is A, right?
Yeah.
So now look at PR by NP then. PR by NP. So it is cos A, right?
Yes, sir. Base
Base
by
by
hypotenuse.
hypotenuse. So
Yes,
this
sir.
is cos A. And what is NP by OP? NP by OP, right? So that is clearly perpendicular by hypotenuse, no, for this angle.
Sign B.
So sine B. So we have proved that sine of A plus B is equal to sine A cos B plus cos A sine B.
Yes, sir.
Okay, so that is the proof that is there in SL. Exactly similar proof with a different diagram will give you the cos A plus B. Okay,
Yes, sir.
so cos A plus B will also come, and that is going to be equal to cos A cos B minus sine A sine B, right?
Yes, sir.
Now from these two formulas, will basically derive everything. Basically, the next 2-3 chapters can be derived from just these two formulas. So sin A cos B plus cos A sin B. You should remember this very well. And what I want you to focus on is how do we derive the others from here? Like, how does this formula help us get many other things, right? That is the important part here.
Yes.
So cos A cos B minus sin A sin B. The first thing that we will get is what is sine of A minus B and what is cos of A minus B, right? That is the
Yes,
first
sir.
two new results that we'll get from here. So what is different between A plus B and A minus B, right? You have replaced B with minus B,
Minus
right?
B.
So let's replace B with minus B in this formula and see what happens, right? If LHS I have replaced B with minus B, right? RHS also I should do the same, right?
Yes, sir.
So the formula should be sine of A minus B is equal to sine of A cos of minus B plus cos of A sine of minus B, right?
Yes, sir.
Now cos of minus B is what?
Cos B.
So that is not minus, it will be some
Yes,
simply
sir.
cos B. And what is sine of
Yes.
minus B?
Minus sin B.
So this is becoming minus sine B cos A, right?
Yes, sir.
So that is the formula, sine A cos B minus cos A sine B for sine A minus B, right?
Yes.
Sine A cos B minus cos A sine B. And similarly, here also I'll do the same. Look at this formula, put minus B instead of B, right? So it becomes cos A cos B remains same, but sine B remains negative. So it becomes cos A cos B plus sine A sine B, right?
Yes, sir.
You understand?
Yes, I just substituted B with minus B.
So this is the first two things that we have gotten. Then the next thing that we will get is what happens when we do sine of A plus B plus sine of A minus B, right? What do you get? Now look at sine of A minus B and add it to sine of A plus B, right? Correct.
Yes, sir.
You will get what? 2 sine A cos B, because the plus cos A sine B will cancel the minus cos A sine
Yes,
B,
sir.
right? Now we will use this in a nice way. So for example, what we can say is, let's take A plus B as X, A minus B as Y, right? So can I write this side in terms of X and Y? Yes, I can. I know
Yes, sir.
X plus Y is equal to 2 times A, no?
Yes, sir.
And what is X minus Y is equal to 2 times B, right?
Yes, sir.
A is equal to X plus Y by 2 and B is equal to X minus Y by 2, right? So this is
Yes,
equal
sir.
to 2 sine X plus Y by 2 cos X minus Y by 2, right?
Yes, sir.
So you're getting a new formula, sine X plus sine Y is equal to 2 times sine X plus Y by 2 cos X minus Y by 2, right?
Yes, sir.
You understand what has happened? We have taken
Yes,
the
sir.
two basic formulas, added it, gotten 2 sine A cos B, but I don't want to write it like this because remembering this doesn't help much, because actually the questions will be like, find the value of sine X plus sine 2X, right? Something like that.
Yes, sir.
So questions will be like that, right?
Yes, sir. Got it.
So I want to know a direct formula for this, not for some intermediate formula when I need to know sine of A, what is A and all, right? I don't want to figure out A and B.
Yes, sir.
I want to be able to say what is sine of 30 degree plus sine of 45 degree plus sine of 60 degree, right? It should be 2 sine 30 plus 60 by 2. So that is 45. into cos 30 minus 60 by 2, that is 15, right?
Yes, sir.
So something like that. So this is a very useful result. So now we can derive 4 results like this. Basically 4 results like this I want you to see is sin c plus sin d, sin c minus sin d, cos c plus cos d, and cos c minus cos d, right? So why don't
Yes,
you try to try to find the 3 other formulas? So I've already found that 2 formula here, one formula here for you. 2 sin c plus d by 2 cos c minus d by 2. You understand how we got this, right?
yes, sir. It's the same thing as the last one.
I mean, that is the last one, right?
Yes,
So find these 3 using similar methods. You have to basically use the identities that you know for sine of a plus b, expansions, sine of a minus b, cos of a plus b, and cos of a minus b. Using that, you will be able to get all 3 other formulas. Don't look at the book, do it yourself.
yes, sir.
Find these 3 other ones. Try it. Are you getting the other 3?
Yes, sir. It's the same thing.
Not same.
Like, it's not exactly the same, but the method is the same.
2 sine c minus d by 2 cos c plus d by 2, right?
Yes, sir.
And this will come out to be 2 cos c plus d by 2 cos c minus d by 2, right? And this comes out to be 2 sine c plus d by 2. Here you have to be careful. It is sine d minus c by 2. Because actually it comes out negative. Minus 2 sine c plus d by 2 sine c minus d by 2. This is what comes actually for this one.
Yes, sir.
Why? Because what I have to do is I have to do cos of, suppose, a plus b minus cos of a minus b, right? Cos a plus b will be cos a cos b minus sin a sin b, and this will be minus cos a cos b minus sin a sin b. So it will be
Yes, sir.
minus 2 sin a sin b, right? And now
Yes, sir.
putting this as c and this as d, you can write it as minus 2 sine c plus d by 2 sine c minus d by 2. And this minus sign is sometimes taken inside. You write it like this sometimes. Because here you can take minus and it can come out, right?
Yes, sir.
So these 4 formulas, no, are super important. These 4 formulas, 1, 2, 3, and this is the 4th one for cos c minus cos t. Immediately don't try to mug up everything. If you cannot remember immediately, it's fine, but you know how to derive it. That is more important, right?
Yes, sir.
So if you are ever in doubt, you can just simply derive it in 2 minutes and then check and then proceed. Don't try to mug it up by brute force. Like,
Yes, sir.
it will happen in problems. When you solve it, you will see enough number of times this that you will have to eventually it will be in your memory. So this is very important. Then you also have the opposite version of this. The opposite version of those formulas is also sometimes useful. So for example, if someone asked you 2 sine c cos t, how to express it as a sum or difference of 2 sines, right? And obviously I know it is sine c plus d plus sine c minus t, right? The opposite version of this. Just now we have simplified that only. No, we took x and y here and wrote it as x plus y by 2 and x minus y by 2, right?
Yes, sir.
So this opposite version also sometimes is useful, because sometimes it might be that you have a product of 2 sine cos and all, and you need to make it into a sum or difference, right? If that is the problem ahead of you, then use this version. Similarly, you can say 2 cos c sine d will be sine c plus d minus sine c minus d, right? Because sine
Yes,
c
sir.
cos t will get cancelled, but cos c sine d will get added here, right? Similarly, 2 cos a cos b, suppose somebody says 2 cos a cos b will simply be cos of a minus b plus cos of a plus b, actually, right? Simply, right? These two can get added and you'll get this, right?
Yes, sir.
Are you understanding? I'm just thinking about the expansion of each of them and thinking about the final formula as a result of the expansion, right?
Yes, sir.
So if you are in doubt about these, what you have to think about is what is sine c plus d? Sine c cos d plus cos c sine d. And
Yes,
after
sir.
that, what is sine c cos minus d? The sine c cos d minus cos c sine d. So cos c sine d gets cancelled and it becomes this, right?
Yes, sir.
Similarly, everywhere. Suppose somebody had 2 sine a sine b. That will be cos of a minus b will give a plus sine a sine b, and then subtract cos of a plus b, right? So this gives, generally in the regular formula, cos of a plus b has a negative sine a sine b. So when you do minus of that, it gets added, right?
Yes, sir.
Are you getting all of these?
Yes, sir.
Okay, so these 4 results and the previous 4 results, very important. you have to use that to simplify many things. Then that's not all. This will help us give many things in the next chapter also. So for example, if you have sine of a plus b and cos of a plus b formulas, which I will write here, sine a cos b plus cos a sine b, cos a sine b, and here you have cos a cos b minus sine a sine b. So now, can you find a way to find sine of double angle, sine of 2a? What is that? Can you find a formula for this? Using this, can you do that? Think about some what can you do here to make this?
So you can use B as like A plus A.
Just b is equal to a. If it happens, it will become sine of 2a, right?
Yes, sir.
So that's what will be the formula here. It will become simply
So it's the
2
same
sine a
thing.
cos a.
Sine A cos A plus 2
Right?
sine A cos A plus cos A. Yes, sir.
You will get sine 2a is equal to 2 sine a cos a.
Yes, sir.
So that is the formula for double angle. This is called multiple angle formulas. So now what happens if you have to do cos 2a? Put b is equal to a in this formula.
Cos A plus A.
Cos a plus a. B is equal to a here. So it becomes
So
cos
cos A
square a.
cos. Yes, sir. Cos square A minus sine square A.
So this is the formula for cos. This formula has three versions. Sometimes we'll write it like this. Right now it has both cos square and sine square. Sometimes you can do cos square a minus 1 minus cos square a. So it becomes 2 cos square a minus 1, right?
Yes, sir.
Or you could even have done 1 minus sine square a minus sine square a, right? So this becomes 1 minus 2 sine square a, right?
Yes, sir.
These are the three versions of cos 2a, which is actually all of them are valid, right? You're just using the identity.
Yes.
Convert to other forms. So this version and this version are sometimes useful because you can say, what is cos square a? Cos square a is simply 1 plus cos 2a by 2, right? Take 1 this side. 1 plus cos 2a by 2 will be cos square a, right?
Yes, sir.
And what is sine square a? Sine square a is 1 minus cos 2a by 2,
2.
right?
Yes, sir.
So these two identities are useful. So now, right now we have been able to get cos and sine double angles, right? Now what about, suppose somebody asked you, what is sine 3a? Suppose
A
somebody asked you
plus
a formula for
2A.
this. So now what I will do here is I will put b is equal to 2a, right, in this.
Yes, sir.
B is equal to 2a. So it will become sine a cos 2a plus cos a sine 2a, right?
Yes, sir.
Okay. And now cos 2a we already know, right? We know what cos 2a is. Cos 2a can be written as cos square a minus sine square a. It can also be written as 1 minus 2 sine square a, right? Just now in the previous
Yes,
page
sir.
we derived that.
Yes.
Plus cos a into, this is 2 sine a cos a.
Yes, sir.
Sine 2a also we just now derived. So we get sine a minus 2 sine cube a plus 2 sine a cos square a, right? Which is 1 minus sine square a.
Yes, sir.
So this becomes sine a plus 2 sine a. So 3 sine a minus 2 sine cube a minus 2 sine cube a. So minus 4 sine cube a. Right?
Yes, sir.
That is your sine 3a. Okay. Similarly, By the same logic, if I do it for cos a plus b and do b is equal to 2a, I'll get cos 3a formula also, right?
Yes, sir.
Cos 3a will come as 4 cos cube a minus 3 cos a. You can derive it for yourself. It's not very hard.
Yes,
So
sir.
basically, any higher angles and all, you can slowly get the formulas. Now if you know sine 3a, you can get sine 4a now, right? Sine 4a will
Yes,
be
sir.
a plus 3a or
3A.
something,
Yes.
or 2a plus 2a, whatever you want to do, right? Correct.
Yes, sir.
So what I want to now see is what is tan of a plus b. Tan of a plus b, because sine a plus b and cos a plus b I know, but tan I don't know any formula right now, right? So tan
Yes,
of
sir.
a plus b is simply sine of a plus b by cos of a plus b, right?
Yes,
Correct.
sir.
So let's expand here. So it becomes sine a cos b plus cos a sine b, cos a sine b divided by sine cos a cos b minus sine a sine b, right? Now here, this is the expression after putting the two identities that we have learned, right?
Yes, sir.
Now divide up and down by cos a cos b. If I divide up and down by cos a cos b, numerator also, denominator also. See what happens in the top. If you divide by cos a cos b gets cancelled and becomes sine a by cos a or tan a, right? Plus it will become cos a will get cancelled here, it will become tan b. What am I doing? Dividing up and down by
Cos A, cos B.
cos a cos b. So here denominator will become 1 here, 1 minus tan a tan b.
Yes, sir.
So that is the formula. Tan a plus b is equal to tan a plus tan b by 1 minus tan a tan b, right?
Yes, sir.
So tan of a plus b becomes tan a plus tan b by 1 minus tan a tan b. Similarly, if I put b is equal to minus b here, it will become tan a minus tan b by 1 plus tan a tan b now. Correct? I have put, instead of b, I have put minus b.
Yes, sir.
And tan of minus b is minus tan b. Now, if you have the tan formulas, you can get now tan 2a also. Tan 2a will be simply 2 tan a by 1 minus tan square a, right?
Yes, sir.
And if you know tan 2a, you can get tan 3a. Tan 3a will be tan of a plus 2a, right? After simplification, it will come out to be 3 tan a minus tan cube a by 1 minus 3 tan square a. Something like this will be tan 3a. After all the simplifications, you know what simplifications you have to do, no? You have to put this in this formula, right?
So which form?
How will you do tan a plus 2a?
So you just change B to 2A, so you can
So which formula are you using?
tan A plus B.
So that only I'm saying, no? Which formula?
Okay,
That
yes.
formula, obviously. Then after that, you have to put tan 2a as this in the expression that comes, right?
Yes, sir. Yes, sir.
Don't take notes, pay attention to what I'm saying and what I'm writing. All
Yes,
of
I'm
this is
listening.
recorded. Okay. So don't take notes, pay attention. So tan 3a, we have gotten the formula, and Okay, so double angles and triple angles you are now able to get. So for example, you can get sine 2a, cos 2a, sine 3a, tan 2a, so on, right?
Yes, sir.
Tan 2a and 3a also, 3a angles also for all of these three ratios. Uh, that that is not all. We can also get results like this. We can also write sine of a is equal to sine of a by 2 plus a by 2, right?
Yes, sir.
Now half angles, basically half angles also we can simply use like this. So this will become sine a by 2 cos a by 2 plus cos a by 2 sine a by 2,
Yes, sir.
right? So this will be simply 2 sine a by 2 cos a by 2, right?
Yes, sir.
So that is a half angle formula. Sine a has become 2 sine a by 2 cos a by 2, right? Similarly, cos a can also be written using half angle formulas, correct?
Yes, sir.
So this will become cos square a by 2 minus sine square a by 2 using the knowledge of cos a plus b that we have, right?
Yes, sir.
Correct. So this can also be written as obviously 1 minus 2 sine square a by 2 and 2 cos square a by 2 minus 1 minus 1, right? I'm using the identity sine square a by 2 plus cos square a by 2 should be 1, right? One time I'll use it for cos and one time I'll use it for sine. So I'll get three different versions. No,
Yes, sir.
this is something that we had done earlier also, right?
Yes, sir.
So what we can say from here, these two results is that sine square a by 2 is equal to 1 minus cos a by 2, right? And cos square a by 2 is equal to 1 plus cos a by 2, right?
Yes, sir.
So sine a by 2 you can write as a root of this and stuff. But basically the point is that you are able to get half angles also, not just double angles. You are able to get half angle formulas also, no?
Yes, sir.
Because you can say as a is a by 2 plus a by 2 and then just use the formulas of sine a plus b and cos a minus b and so on, correct? So
Yes,
now
sir.
let's look at the chapter 7. Chapter 7, see, first section, it is all about the four basic formulas: sine a plus b, a minus b, cos a plus b, a minus b, right? Correct.
Yes, sir.
So exercise 13 on page 72 is about those four formulas only. So you should try these exercise 13 questions. Then
Yes, sir.
look at the next page 73. These are the four formulas that we derived in the beginning: sine c plus d, sine d, and sine c minus sine d, cos c plus cos t, and cos c minus cos t. These are
Yes, sir.
possibly the most important formulas in this chapter. Like, this is used a lot, okay? Many times you'll have situations to use this formula 1 2 3 4 that is here.
Yes, sir.
So you know the derivation of it, right? How it comes, you know, correct?
Yes,
No.
sir.
So then exercise 14 is a long exercise, but it is totally doable and you have to practice it. Exercise 13 and exercise 14. For example, exercise 14 has a lot of proofs and all. Prove that.
Yes, sir.
So one example that we can take is, let's say, question number 23, exercise 14. Question number 23. Question 23 says that prove that sine A minus sine B, sine A minus sine B by cos B minus cos A, right? You have to prove that this is equal to cot of A plus B by 2, right?
Yes,
So
sir.
how will I do it? Very simple. I have sine A minus sine B in the numerator, and I know how to handle sine C minus sine D. It is equal to 2 sine A minus B by 2 cos A plus B by 2. So right now you might not remember that. But I remember that because I've done it for many years. But you don't remember that right now. So you have to
So every
refer to
time
the.
we use these results, would I need to like derive it if I don't remember it?
If you don't remember it, you need to see it enough number of times to remember it. You have to know how to derive it though. You cannot be like, I don't know the
No,
derivation.
so I know how to derive it, but I won't remember exactly what it is.
So do whatever it takes, remember it.
Yes, sir.
But in the beginning, you'll have to derive it, right? You don't
Yes,
know,
sir.
then you'll have to derive it or something. Or remember it. It's up to you. But eventually it has to be remembered. So cos B minus cos A, for example, will be 2 sine sine. 2 sine A plus B by 2 and sine D minus C by 2. So A minus B by 2. This is what is coming. So immediately if you see, if I divide this, automatically this part is cancelled, right? And what is left? Cos A plus B by 2 by sine A plus B by 2, which is cot A plus B by 2, right?
Yes.
So the questions in this exercise will be fairly easy. Some of them might be slightly long, but it will be about intelligent application of the formulas that we have just learned. Okay. Exercise 13, 14. Then the next one is obviously the reverse of what we just now did. I had written this also. 2 sine A cos B can be written as sine of A plus B plus sine of A minus B, right?
Yes, sir.
2 cos A cos B can be written as cos of A plus B plus cos of A minus B. So this one also has its own exercise. Examples 15. Then he has done tan A plus B, tan A minus B. That will have example 16. Okay, so that is the end of this chapter. So 13, 14, 15, 16 are the 4 exercises here. These 4 exercises, we have already done the theory, so you can attempt any questions from these exercises. Then the next
So
chapter,
how many do I do?
how many do I do as in?
Meaning in each exercise, I solve all the questions.
We have already had this discussion, no, last week.
So
Did I
you
tell you to
said
solve
for
all the questions?
so you said for you can leave similar questions.
So that is still valid. Similar questions, whatever you feel you already know, don't do it.
Okay, yes, sir.
Don't do repetitive questions. Do whatever feels like it is different.
Yes, sir.
In the next chapter also, exercise 17, we have already done the theory. Multiple angles we have already done. Tan 2a, tan 3, everything I have derived. So exercise 17 is also doable, and similarly exercise 18 will also be doable, I think. Let me just check. Exercise 18, question numbers. Okay, till question number 22. Exercise 18 till 22. Till question 22. Till here you can attempt. From 13
Yes,
to
sir.
18 till 22. So that is the stuff. And with that, we'll come to the end of this chapter. Then the next section, what we will see in the next class only, after we have done a little bit, after we have attempted questions from here and we have solved some of your doubts and all, then we'll continue. There is one tiny section that is important after this. The next section, which is right before examples 19. That is important, and then we'll go on to chapter 9 and so on. But what is more important is practicing these six exercises, and making sure that you are getting the confidence of being able to apply these formulas. There are a lot of formulas, so unless you practice with enough questions, you will not be able to remember them.
Yes, sir.
And you will not get the confidence. Most important thing is the confidence that whatever comes, I will be able to simplify somehow, right? It will come only with some exposure and some practice. So do that, do these exercises. There will be many problems, but we'll solve them. You don't have to worry about it. But don't give up very easily, right?
Yes, sir.
Don't give up very easily. Don't give up like at the first sign of trouble. Don't surrender. That is the whole point. Try, keep trying. Try
Yes, sir.
multiple approaches. See why it is not coming. See, refer to the formulas in the book. Try again. Then you learn. Okay. That's all for now. Tomorrow we'll do physics. And
Yes,
physics, I
yes.
have to do calculus only. So calculus last class, how much had we done?
So you told me to read chapter 1 and 2.
Okay, so read chapter 1 and 2 and come from Thomas and Finney.
Yes, sir.
It is about limits, right? Chapter 2. Chapter 2 is derivatives actually.
Chapter 2 is derivatives, chapter 1 is limits.
So read derivatives chapter and limits chapter at least. If you have read it enough, then I can proceed faster there. Okay.
Yes, sir.
Okay.
So also 23 onwards, what is that?
What 23 onwards? What
In the 18th exercise. You
23
said do
onwards
till
is
22,
you
right?
don't need to do it. 23 onwards.
So we're not covering it.
No, till
Okay.
22 you have to do it. Okay.
Yes, sir.
Okay. That's all for now then.
Thank you, sir.
Bye.
Bye.